Okay, Rani, share na.
Yes, miss.
Yes,
Yes,
miss.
miss.
Na-share na,
Okay,
miss.
thank you. Sige. Kasi nakuhaan ba sa akong net. Okay, so this is the last topics for lecture, module 9 and 10. And this is the also the last coverage for your P2 exam for lecture. So this is just quite short and I hope we can participate. Everyone would share their ideas. But before that, I would like to start on the overview of our chromatographic theory. So our module 9 is simply separation techniques, no? And our module 10 are the miscellaneous methods for identification or separation or anything. Okay. So I hope when you read your module 9, you already had an idea of what is it all about, diba kay? Ang title niya is Separation Techniques. So that means that chromatography is actually about separation of substances or knowing kung pila ka buok or unsay naa nga substances present in that certain compound. So in here, for example, you have a mixture, no? You have a mixture, and a mixture has different substances present. You have here the red one, the blue one, and the other dot. So, mo ni siyang signify na ang mixture, daghan gyud siyang sulod. Ang kaninga compound, daghan siya. And then, through your separation techniques, for example, your chromatography, there is separation that is happening. And the separation will allow you to identify how many and what are these components present. So in here, na-separate na, no? Wala na sila, di na sila one mixture, di na sila together. They are separated already and grouped accordingly. Components of component like red, blue, the dot, and your yellow. So what happens in chromatography? There is separation, okay? And after the separation class, it depends now on what you want to proceed with. Okay? So, si chromatography, separation na dun siya. Moro siya yung buhat na, iyara kang ingnon nga, na ay upat ka components present ani nga mixture. Okay? However, chromatography will not be able to analyze for you, identify for you, or purify or quantify for you. Ang si chromatography, igo-ergid siya mo, determine nga na ay components present. However, if you want to proceed to analysis, identification, purity, and quantification, na po na siya laing instrument na pwede nimo isumpay sa imo ang chromatography. I hope that's clear. So only separation that is happening here. And if you wanted to proceed to another analysis, identification, and etc., na kay idugang sa imo ang chromatography. Okay? Okay, Ra? Is that clear?
Yes, miss.
Yes po.
Okay. Clear. Next, kuan pa man, nagsugod pa man ta. Okay. So simply your chromatography is separation, no? That's what I've been saying. Have you at least performed this one maybe in your senior high? Na may nga mga experiments? Wala.
Nasa sa
Yes,
biochem
miss.
po.
Biochem,
Okay.
miss.
Okay. You were able to perform it at home?
Yes po.
Yes po.
Yes,
Okay.
miss.
So bright hindi kayo mo ani.
Di pa, miss.
Ayaw
Yeah.
pailad, miss.
Diba? So what sige, hindi na magpailan. What did you have in your biochem? So you had a TLC plate? What did you have?
Miss, vegetables, man to niya. Amura gidip ang paper.
Paper chromatography ra, miss.
And then,
Carotene of
so na
chlorophyll
pinakita
na creation.
okay, na pinakita ang separation.
Yes,
Yes.
Yes,
miss.
miss.
Yes, miss.
Okay, that's good, that's good. So at least no kanang na-imagine na di ay nga ingana ang imong chromatography. So ingana lang po si TLC, si paper plate, no? Si paper plate. Paper siya, paper sa TLC. So, ingana sa dito sa when we perform it inside the laboratory. So, however, sa laboratory lang, we have are really using chemicals like hexane, your acetone perhaps, ganyan na siya. So kato siya, at least, no, you've already experienced this chromatography. Okay, so kano siya. There are separation. So how many components did you find? Chlorophyll lang, ang kuan, identify.
Nasa katong
Carotene, Miss.
Okay, so you had color green and color orange. How many colors did you have?
Yellow po, Miss.
And red, Miss.
Oh, dahil so kanina ay sila din. So the different colors, no, tells you the different components. Okay? So expert maayo na din mo ani. Kaya ba na mo sa overview sa chromatography. Okay. Who's your biochem?
Miss Joshea po sa lab.
Sa lab. Okay. And then for lecture, Ma'am Honey?
Miss
Miss Rose.
Yeah,
Miss Rose.
Ma'am Rose Hanalin. Okay. So that's good. That's good. So in here, so I've highlighted some topics, no, for your module 9 and 10. So we'll try to explain it, no, and then you also I've decided that I should be able to call everyone from the group. So there may be questions, other questions. Also, if there are clarifications, no, maybe because it was different from your references, no, and then it's different from your SAS. You just have to inform me so that I could recheck somehow, no, if unsay difference sa ato ang mga nabasa sa internet and also our books, because sometimes, no, they are using different terms and different principles when they do their experiment as well. So let's maybe we can work it out lang, okay? So for the first one is kato kabalo na mo, no, na there is really separation that is happening during chromatography. So let's try to get to know some terms that affects the separation of our some of our components in the mixture. So we have Bargamento, Co, Cabrera, Keith, and Mindova. So can I have Mindova to tell us what is affinity?
Hey.
So yun yung affinity. I'm sure you have this one in your PCOL. So, no, you have this one in your PCOL and maybe in your biochem. So affinity, Mindova. Nag-breakfast pa si Mindova. Is Mindova here?
Morning, Miss. Sorry.
Nakabaan si Mindova. Sige.
So affinity is the extent or proportion to which a drug binds to receptors at any given drug concentration.
Binds to
The
what else?
the firmness with which the drug attaches to the receptor is referred to as affinity.
So you could also say that there is attachment. Tama ba? Do you
Yes,
agree?
Miss.
Bargamento? Agree ka sa mo ang groupmate?
Yes, Miss.
Is there anything you would like to add? Maybe you have an example?
Yes, Miss. So, di ba this term is not new to us. For example, sa specific drug molecule, it has its own affinity or attractiveness to a specific receptor. So, for like histamine, Miss, it is attracted to its histamine receptors. And then, other example is, kanang magjowa, Miss, ikaw, gimong uyab, kaya na mo'y affinity to each other. Except sa mga single diha nga wala yung affinity sa ilang crush.
Yan, nangigo siya. Sama na to ni si Bargamento.
okay rami dyan, okay rami.
Alache.
Okay, no? So very good, no? Very good association for the drugs and also for our life, no? In a relationship, there is really affinity, and very good that you were able to kaning really say that you are no longer new to affinity because I remembered you also have this one in your PCOL. Okay. So how about Cabrera? Is there anything you would like to add for affinity? Si Keith?
Um, in simple terms, ma'am, it is like a degree of attractiveness, or it's
Yeah.
like a strong liking or attraction to someone or something.
Degree of attractiveness. Yes. How about ko? Parang nagsika, basta parang nanggod namin yung mastorya, madungay yung mga nindot nga tingog.
Hello.
Hmm. Dili makakuan si ko. Okay. Sige. So, very simple, no? Affinity is definitely the degree of attractiveness, ano ba? Attachment, or so in terms of drugs, there is binding, no, to your receptor. So si receptor, mura po ni siya o parking area, no? So you have your drug as your car and your receptors as your parking lot. So kailangan sakto yung pagsulod sa parking lot. And the affinity, ang affinity ato in between nila because luag na ay space for your parking. So very easy for that one. Thank you, Bargamento, Cabrera, Mendova, and Co for that one. So together with affinity, no, when we talk about chromatography, we're also talking about adsorption. And when we say adsorption, it is a property of how well a component of the mixture sticks to the stationary phase, no? So we'll need stationary phase in a while. Stick, so meaning, also yung adsorption? Is it attaching in the surface or going inside?
Surface, miss.
Surface.
Phase lang, no? Adsorption. So, adhere lang. So, mo na siya itong mga terms na we have affinity and we had adsorption. Together with chromatography, we also have solubility. So this is the property of how well a component of the mixture dissolves in the mobile phase. So ganina, adsorption, it talks about your stationary phase. So solubility, kay mobile phase man, no? The mobile phase is the one that is moving and is also could be in a liquid form. So dapat na ay makuan siya, ma-mix jud siya, ma-dissolve jud siya, kay dapat soluble siya because we're talking about mobile phase. Katong adsorption, surface lang, di ba? Because your stationary phase is dili man siya move, di ba? Siya man siguro ang, let's say, siya ang solid. So, kailangan mo adhere lang siya sa surface sa imo ang stationary phase. Okay? So, kuan na siya, overview lang sa. Okay? So, we had affinity, we had adsorption, we had solubility, and most importantly, we have polarity. Familiar si polarity?
Yes, miss.
Okay. So,
Yes, ma'am.
polarity, look ha, si polarity is the most powerful of the four terms. It dictates the affinities towards the stationary phase and your mobile phases. Si adsorption, it talks about stationary phase. Si solubility dwells on mobile phase. Si affinity is dependent on the polarity. Diba? So, unsa din yung polarity? Can you sa man yung ma-remember sa polarity? Sir, any idea about polarity? Maybe you can try.
Hinumduman ako, miss, kay water.
Okay, so your water is polar. Okay. Actually, in between siya, no, your alcohol is also polar.
Miss.
And kani siya, you have many parts, no? You have polar, non-polar, and less polar. So, pwede, tanang ninyong may bawaan nga, liquid or solutions or maybe any substances could be polar or non-polar. It now depends on how much. Pila ila ang polarity, no? So, meaning pila ang lang intensity sa ila ang pagka-polar. So, the polarity dictates the affinities of your substances towards your stationary phase and your mobile phase. Okay? So, kana lang sa, let's leave that one here. So, okay, si polarity siya di ay ang mag-guide siya ang magbuot halos kung asa taman ang imo ang mobile phase sa imo ang stationary phase. Okay? So, we had now 4 terms: we had absorption, solubility, affinity, and polarity. Okay, so when we go to the next topics, no, we'll try to go back on unsa jud di IC polarity. Okay, so i-leave sa nato na siya nga okay, polarity. Kabalo naman mo na because you had this one also in your PCOG, diba? Medyo marami siya. Nahapon siya sa biochem, siguro. Next is, we explain now the TLCs. Hindi na siya, saan loving,
Tender loving care, miss.
tender loving care, okay. Sige, so, and we also have to describe its parts, okay. Okay, Tirando, can you tell us about our TLC, thin layer chromatography?
Thin layer chromatography miss is a spotting of a sample of a mixture of components at one end of an adsorbent coated glass plate or other suitable support, followed by the passage of a solvent through an adsorbent for the purpose of separating the components of a sample po. Or it is an affinity-based method used to separate compounds in a mixture.
Separation in a mixture. Okay, so si TLC, mao ni siya ang sa bagong, hindi siya bago dyan, pero mas daghan na gamit siya because it's easy, no? And it's also less costly type of chromatography. So what you perform maybe in your house during your biochem, it was only the first and most common chromatography, which was paper chromatography. Okay. Is there anything you would like to add, Dulos? For TLC? Dulos?
Ay, sorry, ma'am. For TLC po, yeah, as what you said, it was the easier one, and also this is a technique in identification for the compounds and to determine the purity of the following or the progress of a reaction, and also a separating technique by its differences in polarity.
So, polarity. So, si TLC, no, it's based on polarity, and as mentioned ganina, affinity also. Thank you. Arado, can you tell us about the maybe parts of your chromatography? What are the parts do you know about chromatography?
So there are three common parts sa TLC that is always mentioned. So we have TLC chamber, we also have the solvent system, and also the silica gel rather. The chamber is the stationary phase, in which it is responsible to keep a steady environment, which will help in developing the spots. And then the silica gel is a it is a polar absorbent with slight acidity, which enables it to absorb the basic contents in the material. And then the solvent system, it is which that helps. It is used to help to separate the components of a mixture. So those are the three common parts of the thin layer chromatography.
Thank you, Arado. How about Ingilio? Is there anything you would like to add for the parts of the TLC?
Yes, miss. There is also a UV light used for visualization for aromatic compounds and highly conjugated systems, and a staining agent or iodine used to stain. Then it sublimes and reacts with the compounds in the plate forming yellow-brown spots.
Thank you. No, thank you for mentioning UV light, no. So your TLC has many types, no. So naga-upgrade man jud ni sila. So usually what we had, like what you have performed in your houses, kay di ba namoy colors nga makita, and also kani said sa examples, there are colors nga mahitabo, no. There is actually separation na mahitabo, and it is indicated by color. But take note that not all substances have their colors. No, hindi lahat makulay ang buhay. So, maybe there is separation that is happening. However, dili mo siya makita in your naked eye because most of them are color brown tanan or colorless. So, what do they do? So, when they separate, no, using TLC, so this is just an FYI, when they separate using TLC, what happens after the separation? Wala sila makita kay dili mo siya colored, no? Wala yung nakita nga separation. But the moment they put it beyond and use UV light, makita nila ang separation. Okay? So, kana lang. So, makuna na mo, what if, while unya ba, maglakaw-lakaw mo sa inyong balay, what if ang substance kahano walay color? So, mo na to siya ang answer. It can still be separated, however, after ni mo separate, wala kayo makita. You have to have a UV light. And you have to perform this inside a dark laboratory. Okay, para makita ni mo ang separation. Okay? So, thank you for that one. So, in here, you have your chamber, and you have your paper, your solvent, no? And your solvent front, which is taman dito ni Dagan in ang mobile face. O in ang solvent, sorry. So, as mentioned, so how did you perform yours? Baso lang or any material?
Baso lang po.
What did you use as a solvent?
Hot water, miss.
Yeah, it should be hot water para na interaction. I handled biochem, but I was for lecture, so I'm quite amazed for the laboratory. So at least na experience hot water, and you were able to nag-video mo and send the pictures, the results. Is it by group or individual?
Individual.
That's good. Para
Individual.
Merge na siya para ma-experience. Okay, that's good. So as mentioned, we have stationary phase and mobile phase for your TLC. And all throughout the chromatography or the separation techniques, we'll always use stationary phase and your mobile phase. So sa stationary phase, siya yung fixed in place, no? And your mobile phase carries the components of the mixture. So you know that already. So that's for your TLC. Thank you, Ingilio, Terando, Arado, and Dulos. Thank you. Easy lang. Okay. So I think before I go to the next one, I need to explain what happens during the separation. So sige pangayo sa inyo ang, let me use your biochem, no? Allow me to use your biochem kana experience man jud ninyo. So, unsang inyo ang mga conclusion about sa inyo ang experiment? When you did your experimenting, ani pud ba naay nag-una nga mga separate na components na nabilin sa man?
Yes, miss.
Yes, miss.
Okay. So, what were you able to conclude man? Were you able to know if nganong layo ning red, example, no? Nganong layo ning red, tapos nganong duol ning blue? Were you able to explain and justify these things?
Ang sa amo miss kay different solubility siya moong lain-lain ang abot sa sa colors.
No, you go back to solubility na pod na term, no? So, dagan kayong involved sa separation techniques. Anything else? So, pa inyong ma-remember. Okay, there is separation because there are also differences in their solubility. What else? So, kay pasabot nga nung duol ning blue tapos layo ang red. So let me get to that. So you know already that when you performed your activity, you created a baseline, no? And then your solvent front in here. Okay. And of course, did you also measure?
Not miss.
No.
Wow. So that is now for QC. And that will be for the next group. But let me just get an overview. So you have let's say for example, this is your baseline, and you have your spot, no? We call the components that separated spot. So spot A and spot B. So as mentioned, ingon ko, nganong ang A, tama na siya diri, tapos ang B, nganong tama na siya diri. You also answer that it is because of solubility, and maybe it also because of the difference in their affinities. So why separation happens? So aside from the solubility and their affinities, the most important answer for this one class is actually we go back to polarity. So the polarity, as mentioned earlier, there are difference in the polarity that allows the separation. So maybe si spot A, si spot B, si spot A, dili kayo polar. Si spot B, polar kaayo. So, mo nang layo siya. Or, kung asa mga nikin sinag-una nila, mo na siyang explanation. So, karon makaingon mo nga, it's not just about the solubility. It also, most importantly, about the polarity, which is focusing on affinities. Okay? So, ingon mo, so karon di ay nakasabot ako nga ang chromatography na ay separation. And the separation happens because of the polarity. Okay? Kira? Gets Ra?
Yes, miss.
Okay. So, are you
Yes, miss.
familiar with mga herbal medicines, no? Are you familiar with your MX3 maybe, your NANS, Yaki, kaya ba yung mga tambal?
Yes, miss.
Herbal medicine. Okay, so the herbal medicines class, this is just a trivia or FYI, is actually when they created their herbal medicine, they were dependent on the polarity of their herbal. So let's say for example, ang ilang gigamit silang herbal is malunggay or mangostino, your MX3. Okay, so giusa na napaghimo no nga napunta man jud nila nakuha nga anong nakaingon man sila nga naa jud ni siya power. So what they did was taas po kayo siya process no. So it's not just really malunggay kato okay malunggay kamunggay. Balo na ko nga mao jud ni siyang naa sa herbal. What they did was they get the polarity of the malunggay. So sa malunggay butang ta lang na ay 35 ka components present, di ba? And they only use, maybe naka-identify sila of 15 ka polar substances. Okay? And these polar substances class is said to have the power to give, siya ang naay power no, to treat or siya ang itawag nga herbal, siya ang active ingredient. So that means, dili tanan sa malunggay nga part kay gigamit. It was also dependent on the polarity. Kaya napabaya kay mga excipients, di ba? And then imong excipients, for let's say for example, ang imo ang binders, dili siya mo bind sa imo ang 35 ka components. So imo siyang i-extract, imo siyang gamitan og polarity para kung kisa tong mo bind lang, siya ra tong mabilin para himuong capsule. Okay? So para ba maka-think mo nga, dili lang siya about chemicals nga nag-separate. Maka-think sad mo nga, about po siya sa herbal medicines, no? Nga, ingani day lang gigamit. So, di lang po siya about sa herbal, pwede po siya sa mga biogesic, sa kanang mga gihimo sa laboratory. So, it also deals with polarity. Ingana ka powerful imo ang polarity. So, kaingon na tag, polar, non-polar, wala lang, no? But at least now we understand that polarity was actually part of the discovery of the drug. You go back to your dosage. Hinay lang. Murag naabot na ka og dosage balik. No? So, kana siya. So, sink in lang sa. So, it's just an FYI, no? Just maybe someone will ask you, gusto mo pag mo ang herbal medicine. Ano po explain nila? Kabalo ka na 35 ka components. So, ano na nga, mga kuan lang dyan na siya. Kung kuan pa, sa yung gingon, attractiveness of the components, no? To certain components. So, that's how they created the power for herbal medicines. Okay. Are you still there?
Yes, ma'am.
Yes po.
Okay, so yan, even your mga haplas, no, it also dwells on the power of polarity because the polarity allows binding or the attractiveness or suitable siya. It allows the stability, all in all. Okay, so siya ang mag-dictate. Okay, so kato lang siya. Sige. Okay, going back to our chromatography. So, the reason behind there is different, no? The explanation ng anong si spot blue, let's say this is A, and this is B. Si spot A na siya diri, si spot red, B na siya sa tumoy jud sa ibabaw. Because in here, no, the polar components of the analyte will adhere to the silica tightly and thus travel slowly up the plate. So while the less polar or non-polar components will not adhere strongly, the silica travel plate relatively fast with the solvent. So meaning, kinsa ang non-polar? A or B?
A, Miss.
A. And then
po.
your polar, your non-polar,
Tayo naglibot.
kinsa mo ang non-polar?
Si B ang non-polar, Miss.
Okay. And then your polar, syempre, si A pa rin. Okay, let's try. So the least distance traveled in the TLC plate is the most polar. Okay, that's correct. And the maximum distance traveled, pinakalayo si spot B, your red one, is the least polar or the non-polar. Okay. Okay, Clara.
Yes po.
This one is not in your module. So this is new information. So this is also one of the explanations. So you know that there is polarity differences in solubility, no? But at least this time we now know that mo ni siya nahitabo. Okay. So in your module you have reverse phase, no? And you also have your normal phase. Your normal phase is maybe your TLC, your paper chromatography, and your reverse phase is gitawag po siya reverse phase. Anong reverse na nga ni normal? Because remember, you have your stationary phase and you have your mobile phase. If it's normal, the stationary phase is polar. If it's not, and then your mobile phase is non-polar. Okay? If it's reversed, the stationary phase is less polar or non-polar. And your mobile phase is the one that is polar. Okay? So, dili sa tanang panahon nga si stationary phase polar. Dili po sa tanang panahon nga si mobile phase non-polar. So, we have what we call your reverse phase chromatography, which is reverse jud. So, si stationary phase niya non-polar, ang yung mobile phase polar. Okay? Sige. So, let's go to your retention factor. So, retention factor pa din. Sige. Kuan lang ha, ito siyang i-leave dito because the retention factor will now, again, help us to explain again your polarity. Sige. Can I have Lee? What is retention factor?
Hello, Miss.
Or value?
The retention factor of a particular material is the ratio of a distance the spot moved above the origin to the distance the solvent front moved above the origin. It can be calculated using the formula RF equals distance traveled by solute over distance traveled by solvent.
Okay, thank you. Torino. Oh, Lee, no? Lee akong gitawag. Si Lee akong gitawag.
Yes, Miss.
Okay, thank you, Lee. Okay, Kabaho. What is the importance of measuring your retention factor? Ganain mo man siyang i-measure. What do you think? Sheer, no? Sa man, imo lang, ngano kahang ganahan ka i-identify ang you want to know the distance of your solute Your solute is your spots, no? Katong mga components nga na-determine. Sige. Anything? Maybe Torino? What is the importance of knowing your retention factor? Miss Marapang Miss Universe, man ang question alam mo nag-ready ana. Okay. Sige. Okay. I'll give you another question. Torino, if this is your retention factor formula, looking at the same illustration, no, this one, you have your spot red and your spot B. Ano lang, you just lantawon lang nimo kinsa kahaang na ay dako og retention factor, kaning layo og travel or kaning duol lang travel? Or anyone from the group would like to answer that?
Excuse me, miss.
Yes.
Kanang magamit ni siya ang retention factor sa kuan, miss, to other TLC or other kinds of chromatography to compare and help identify the compounds. It is also used to determine the polarity, the relative masses, and also the relative solubilities.
Okay, ito. Harurot is it Torino? Who answered?
Limit.
Oh, si Lily. Okay. So it is for comparison. Yes, very good. So mo lang. No, you wanted to know the retention factor because by knowing the numerical values, no, of your result, you will be able to compare and identify, okay, polar ni siya, non-polar ni siya. So ma-compare nimo, mas layo ni siya gi-travel kaysa ni isa. Okay? So, I'll go back to my question. Maybe Paninahog or Kabahog or Torino could answer. Looking at your RF value, no? Ano lang, you just try. Kinsa kay mas dako og RF value? Kaning blue nga spot or ang red nga spot?
Compounds with smaller RF are more polar since they are more attracted to the stationary phase, and compounds with bigger RF or retention factor are less polar since they are more attracted to mobile phase.
Okay. So, kinsa man ang gamay og RF value? Kaning blue or kaning red?
Kanang blue.
Okay. Sige. Okay. And the red one is the whole RF value, which tells you that it is less polar. So, here, so it is a quantitative parameter, your retention factor. No, you could, daghan man siyang term, no, retention factor, retention value, retention, retention time. So, distance covered by your solute and covered by your solvent. So, as you mentioned, you did not solve for your in your biochem, no? So how do you solve for the RF value in your chromatography? So you have to first measure this one. Okay. So from your origin to your solvent front, no, at the end. So let's say for example this is 20 millimeters. Okay. The next you will do is you have to measure the distance from the origin to the spot. Okay. The next one, measure from the origin to the next spot, which is your green, and measure from the origin to the next spot. Okay. And then your solute, let's say for example, this is a distance of 18, no? See red, 18 millimeters. And then distance covered by your solvent from the origin to your solvent front is 20 ml. That's how you solve for your retention factor. Okay, is it clear? Okay, I have another example. So we have here another one, no? So CC ang pinakaduol nga gi-travel at 1 centimeters, centimeters with CA, which is 2 centimeters, and spot B is 3 centimeters. So as if you can read in here, polarity of the components decreases when it travels further. Okay. So in here, your component C, your spot C traveled 1 centimeters and the RF value is 0.2. And for your spot A's, retention factor is 0.4. And pinakalayo mo travel is siyang pinakadako o retention factor. So, is Torino here? Torino?
Yes, Miss. Sorry, Miss. Yes, Miss.
So, as gimension ni Paninaho ganina, can you tell us if ang C ang pinakaduol nga gi-travel, unsa may pasabot? Polar or non-polar? If gamay ang iyang RF value, unsa may pasabot? Polar or non-polar?
Non-polar, Miss.
Polar.
Ay, polar.
Sige. Kasi mong kontra diha. Sige. Is it polar or non-polar? Ang pinakaduol og gi-travel.
Polar, Miss. Polar. Sorry.
How about kabahog? Ang pinakalayo og gi-travel, which is spot. Is kabahog here?
Non-polar, Miss.
Okay. Which spot? Ang non-polar.
B. Ay, A.
Spot B, AC.
B? A, B.
B, Miss.
Okay. So again, going back, the least distance nga gi-travel sa TLC is the most polar, no? And the maximum distance traveled is now the least polar. So during your face-to-face exam, you will be naani siya, no? Kani mag-compute mo for the RF value, so mag-compute mo na niya. And then you'll be asked maybe kinsa ang pinaka-polar. So at least makatubag na mo. So it is spot C, no? For example, kung siya ang duol. Kung siya pinakalayo gi-travel, that is non-polar. So you will be asked which spot is the most polar, or can you describe spot B? Is it polar or non-polar? Ayan na siya. Okay? So at least nanamoy hint for the exam. So aside from computing, no, simple computation for the RF factor or the RF value, you should also be able to identify kung kinsa ang pinaka-polar o kinsa ang dili polar. Okay, Ran?
Miss?
Yes.
I have a question, Miss. Ang sa kanagaling ilahang units, Miss, need na ECM usa, like what if MM baron ang given, tas need siya ECM usa ka mag-calculate?
Grabe kayo ginahuna si Kuan John Lloyd yun. Hapon na dyan siya. Yeah, if you have to convert dyan. You have to make the two the same. So, if for example, libugon ta mo, pero di ta mo libugon, don't worry. For example, no, I'll answer your question. So, example, centimeters, no? And then ang isa is millimeters, okay? However, sa inyo ang choices, ang unit gigamit kay millimeters. So, that means you have to convert you have to make the centimeters to millimeters. Okay? Ano lang siya.
Okay.
So, maybe dependent lang ta sa choices. But again, no, I will not do that to you. Sige, ha? So,
Okay,
simple.
thank you po.
Libugon. Kaya daghan namang memorize, no? So, but I did try that one, no? So, sa other na ko nga subject, other courses, no? Where I will ask them to convert liters to ml before they could get the answer. So, yung add ko lang. But for the retention factor, it's a very simple lang siya nga computation, di ba? So, let's make it simple. So, kung centimeters lang po naman yan. Pinakinigo na muna si John Lloyd pa.
Miss.
Ang kanipag-question ni Miss, no? Relax lang. Sige. Thank you. So, you have this one in your module, no? Skill building activities. So, very easy for you to answer. So, you just have to divide all the traveled distance to your covered by your solvent. This one is an mm. So, kaya ninyo siya. Ano siya answer key? That's for activity 3. So, I've mentioned the advantages of your TLC, low cost, and ano po tayo term nga, sensitive. Okay? So, if there are changes or fluctuations, ma-identify niya. Or, klaro. Diba? So, muna itong istoryahan gahapon. Sa kanya pag-cope up. So, siguro, mas stop ang TLC or mas smudge siya kay, ay, sayo man yung dili man on the pangitan. So, that should be sensitive. And the types of your chromatography, no? You have your CC, your absorption, your paper partition chromatography, and as I've mentioned, your reverse phase, molecular exclusion chromatography. This is based on molecular weight, and your TLC, this is what you've mentioned. Gas chromatography, na as said, in the later part in your HPLC. So our next one is your GC. Dili ni group chat ha, but your gas chromatography. Very easy. How about, let's have Batukan. What do we have to know about gas chromatography?
Good morning, Miss. Chromatography runs on the principle of partition chromatography for separation of components. In terms of stationary and mobile phases, it is categorized under gas-liquid type of chromatography.
Okay. What else? Sorry, I'll call another. Thank you. Can I have Sahilan? What else do we need to know about gas chromatography?
The mixture of components to be separated is converted to vapor and mixed with a gaseous mobile phase, and separation occurs as the vapor constituents equilibrate between carrier gas and the stationary phase. The organic compounds are separated due to the differences in their partitioning behavior between the mobile gas phase and the stationary phase in the column.
Thank you. Very good. How about Sinchas? Would you like to add anything for gas chromatography?
Um, Majorly, there are two gas chromatography types into which it is classified as GLC or gas liquid chromatography and GSC or gas solid chromatography. Both the methods use either liquid or solid as a stationary phase while using gas as the mobile phase. In gas solid chromatography, the retention of analytes is due to physical absorption. On the other hand, gas liquid chromatography separates the ions or molecules that are dissolved in a solvent.
Very good. Very good for mentioning the two types of gas chromatography, no? Your liquid and your solid. So very good also for saying that even though liquid and solid, the mobile phase remains gas. No? So that's one of the beauty of your GC, your gas chromatography, which is ang yang mobile phase is gas. So carry na siya, gitawag na carrier gas. So definitely it's moving. It is the mobile phase because it is the gas, the carrier gas. Okay. So maybe Sahilan would like to ako nang tawag si Sahilan. Is it Sinchas? Wala na ako natawag. I called Batukan, right? Sorry, I'm lost. Sahilan? Or si Solon? Si Solon, wala na ako na. Si Solon, ako wala natawag.
Ako'y wala na tawag mo.
Sorry, name? Are you Sahilan? Natawag na ko si Batukan, si Sinchas. Sorry, please tell me. Basta ko lang natawag. Si
Solon, miss. Wala na tawag.
Family name. Sorry, dear. Solon?
Sol, miss. Yes, miss.
Okay, sorry, dear. I am so sorry. Sige, Solon. Can you tell us something about carrier gas? Okay, ma-add for carrier gas? Or anything else you would like to add for gas chromatography? Kapay mo ang pwede ma-add for gas chromatography. Wala na?
Wait, Miss Aramis.
Sige.
Compounds that have a greater affinity for the stationary phase spend more time in the column, and those elute later and have a longer retention time than samples that have a higher affinity for the mobile phase.
Again, can you repeat that? The ones that have
a longer retention, Miss.
Can you read again or say again ang sa itong istorya?
Compounds that have a greater affinity for the stationary phase spend more time in the column, and those elute later and have a longer retention time than samples that have a higher affinity for the mobile phase.
Okay, thank you. I'll go to my next slide now before I continue. Thank you, Solon. So again, your gas chromatography analyzes your compounds and which has your carrier gas. So I've also, I think I've mentioned yesterday about your atomic, no, you still remember your atomic spectroscopy. So si atomic spectroscopy sa to yung first na himuan, yang i-atomize ang iyang sample. Okay, same with your gas chromatography. Your sample should be vaporized without decomposition. The same with atomic spectroscopy. When you atomize, when you vaporize into gaseous state of your sample, you should not cause any decomposition. Diba? Nag-use ka og dako kaayong temperature. However, dapat imong i-make sure nga dili jud nimo maguba ang components sa imuang sample. Okay? So, just like your atomic spectroscopy, one thing about gas chromatography is your mobile phase, your sample should be vaporized. Okay? And as mentioned earlier, you have your gas-liquid partition chromatography and your solid chromatography. Okay. So you have this one in your module. So you have the carrier gas. So the carrier gas class, dili ni siya maupadjud ang sample, okay? Diba mo basta na wala na mukha na hiwa na dayong gas. So you have the carrier gas as dito sa inyo ang gas chromatography nga instrument. What happens is you have to inject your sample, no? I-inject niyo yung liquid nga sample. And what happens? So there is a column and then katunain nyo ang burner, no, in order to vaporize it. So the carrier gas will have to blend to your sample. So you have your injector here and your gas should blend with your sample as it flows through your column. Now, aside from knowing na inyo siyang i-vaporize, the most critical part of your gas chromatography is your flow controller. From the word itself, siya ang nag-control sa flow sa imo ang gas, sa imo ang vaporized sample. So, if imo ra di siyang pasagdan, imo ra siyang dili nimo tarungon, it could actually burn down and decompose your sample. So, si flow controller na siya gi-follow nga time, nga speed, nga kakuan lang, na unsa siya kadugaya mo stay. That's why it's called your flow controller. And if the flow controller is working well, syempre, dali jud ang ato ang kuha sa ato ang sample. And if you notice in here, same with your spectro, you also have your detector. Because the detector now will show you your result for your readout. So, siyang mo detect na, mao ni siya, nitabo. Okay? Are you still following? Are you still there?
Yes, Miss.
Okay. Okay. I think so. This was what I asked yesterday. No, I was when I reread again. So I thought that I've mentioned already. So yesterday with your spectro, I asked for the types of detectors that you have. No, so the types of detectors that you have was actually for your chromatographic theory. However, inyo ang detector sa spectro, naapo siya kagalingong detectors, no? But for GC detectors and HPLC, naapo ta. Okay, so going to your detectors, if you read it in your modules, you have there your FID, diba? Your NCD, MyAna. And as I've mentioned yesterday, your detector should either be destructive or non-destructive. Okay? And you know this one already. Okay? So please read your detectors for your module 9 because there's a lot of questions in your exam about it. So maybe you'll be asked which one is non-destructive and which one is destructive. So ang iya pong mga definitions. Okay? So another tips, you have to also identify your detectors for your gas chromatography. So categorize them according to destructive and non-destructive. Okay, thank you, Solon, Sahilan, Batukan, and Sinches. Let's go to, we're still in gas chromatography. Let's have the factors affecting GC separation. So, before we go to volatility, maybe let's identify, unsa di ay ang volatility? Kirante? What is...
Hello, Miss. Okay. Start na, Miss.
Yes.
Okay. So first, let's define the term volatile. The term volatile refers to a substance that readily vaporizes. Now, to define volatility, volatility is a measure of how quickly a chemical or a substance vaporizes from a liquid to a gas state. Examples of volatile substances are alcohol and acetone. Then, the volatility of the compound is one of the factors of GC separation. Why? This is because volatile compounds or the low boiling components travel faster through the column than non-volatile compounds or high boiling components. Less volatile molecules will interact more with the stationary phase, making them move slower. On the other hand, more volatile molecules will interact more with the mobile phase, resulting in a faster movement through the column. Miss.
Very good, thank you. Would you like to add, Villarante? What else do we have to know about volatility?
Yes, Miss. Um, the higher the vapor pressure of a compound, the more volatile it is. Higher vapor pressure and volatility translate into a lower boiling point. Increasing temperature increases vapor pressure. Also, the volatility is related to the size of molecule. This means that smaller sized molecules have a short retention time as compared to the larger molecules. Retention time is the time it takes for a compound to travel from the injection port to the detector. It is reported in minutes.
Thank you very. It is reported in minutes. Thank you. Yes, I no okay because it is dealing with separation, and fast or slow movement of your mobile phase with your stationary phase. Of course, all the chromatography should have time, no? So thank you for mentioning that one. So siguro sa katong nag-perform sa inyong balay, siguro I don't know if you set your timers for that one, but for the chromatography, for the separation techniques, time is also very important because the time allows them to compare if maybe mag-trial 1 sila, trial 2, no? So, ay, mas fast-fast ang trial 1, and yung trial 2, nadugay na noon. So, maybe it's due to the freshness of the sample they wanted to test or other factors. So, very good for mentioning time, especially for gas chromatography. Anything else you would like to add, Yukot? Sa man judi ay ang disadvantage if volatile ang ato ang sample. Na-mention na siya ganina ni Kirante, but would you like to add more or to clarify? Sa man
To
judi
add,
na-
Miss,
Sige, sige.
the more volatile the compound is, the more the gas chromatography separation is likely to succeed.
Okay, very good. So if more volatile sila, of course, so, di ba, when we say volatile or volatile, so meaning, di siya mo stay sa surface or di siya mo stay sa ato ang gusto nga place, di ba? Kaya volatile man kaayo siya. So, instead nga instead nga magstay siya sa atong stationary phase, agi siya ka volatile and then napa jud kay heat, no? Because you have gas, di ba? So there's heat. So paspas noon kayo ang iyaang pag-exit. Paspas ang iyaang pag-volatile. So mahawa siya kalit. Okay? So factors that affects GC includes your volatility because the volatility of your sample affects the very good success of your gas chromatography because if volatile kaayo, makaikyat dayon ng imuang components. Dili mo siya matest. Okay? So that's why also it's very important to make sure that the temperature used to vaporize your sample is the right temperature. Diba? So dili na to kung gipaingon ninyo nga dapat sensitive, dapat robust, yan ano, na dakan kayong factors nga mo affect good sa inyong instrument, sa inyong machines. Okay? Dili lang ang inspiration sa personal. Okay. Thank you for that one. Group Ichea, Alcurante, Villarante, and Yucot. Thank you. How about polarity? Can you tell us about it, Ortizano?
Okay, so we're on the second factor affecting GC separation, the polarity. So as discussed earlier, polarity dictates the affinities towards the stationary and mobile phases. So, unsa day ni ang polar ug unsa day ni ang non-polar molecules? Polar molecules are those with distinct regions of positive and negative charge. The molecule is slightly positive at one end and slightly negative at the opposite end. A non-polar molecule is one where the electrons are distributed more symmetrically and does not have an abundance of charges at the opposite sides, meaning the charges cancel out each other. Alright.
Okay, very good.
Sa polarity.
Yes. Maybe we can hear more from the other members. Dela Cruz.
Hi, Miss. So polarity has a huge effect on how attracted a chemical is to other substances. Some molecules have a positively charged side and a negatively charged side. For example, the positive side is attracted to the negative side of another molecule. So the larger the charge difference, the more polar a molecule is. You will find that as you increase the polarity of the solvent and all the components of the mixture move faster during your chromatography experiment. That's all, Miss.
Hello?
Hello? Miss, wala batian, Miss?
Batian.
I joke, sorry, Miss.
Hello?
Hello, Miss?
Miss?
Wala na batian akong gi-explain, Miss? Uy, saan naman? Wala day, Miss?
Madungog ra ka, Jai.
Nadungog ka na.
Ang katong akong gi-explain ka ganina na batian, guys.
Oh, nabatian nga.
Batian ra.
Yo.
Hello?
Hello, Miss.
Hello,
Miss.
Miss.